Welcome to Godot. A lot of people have been bouncing off of Godot, and that includes me. I bounced off of it for years. I bounce off of everything. But once you get into the groove, you really start to understand what's going on, and the game engine comes alive and becomes useful. It's not a matter of how smart you are. It's a matter of whether or not you can get into the right mood to catch what the game engine is throwing. So I think that we should create Myst. Let's create a Riven-like. A really, really tiny one just for demonstration purposes, because I think this is the easiest kind of game to create in Godot. I would literally call it trivial. So trivial that we're going to do it right here. So let's talk about how to set all of this up for people that are new to Godot and probably new to coding. We're going to create our scenes as user interfaces. You might be tempted to use 2D scenes, and those are the right choice for things like jumping games or RPGs, but for a Myst-like where the scene is just an image or a video, we want the user interface. This user interface is called control. This is the root type for all user interfaces. It does nothing. It doesn't render anything. So it's the wrong kind of control for us. No big deal. We'll change it. Make it a texture. There it is, texture rect. Here we can add in any texture we want. Let's go ahead and add in Mass Effect. Wow. Seems fine. Let's save this as base scene. Now you're going to hear the word scene a lot when you're doing stuff in Godot, and that's because one of Godot's obnoxious quirks is that they use the scene to mean anything you've saved. So that's a little bit obnoxious. I mean, a scene is a scene, right? You can add the scene to the game, but a scene can also be a button. So a scene has a wide variety of meanings. It just means it's a coordinated group of nodes that you can put into the game. And they can be embedded inside of each other. They can be anything you want. So don't get confused when you hear people talk about scenes and they mean like a button. If we hit F5, we can now run it. Let's set the current. Oh, look at that. It's all chopped off. Like it's too big. That's because the screenshot is bigger than the rendering surface. So we're going to want to change that so that instead of keeping size, we ignore the size. There we go. So now when we hit F5 and run it, it's the right size. Beautiful. Now let's add some buttons. We could just add them manually. Button and drag it down here and stuff. But this has a lot of problems. We're not going to do it that way. We're going to go ahead and use some containers. Containers are an entire group of UI elements that control how their children are laid out, and they are the reason that doing UI in Godot is so easy. If you're fighting against your containers, you're using them wrong. Containers should be extremely fluid and fast to use. If there's something going on that you have to kind of work around, it means you're using containers wrong. So find another way to do it. In this case, we want the panel container. So let's go ahead and grab it. And we want it to be in the bottom, in the middle, like this. And we can drag it up from the bottom a little bit. Hold shift to lock it into the vertical drag. There you go. Now let's go ahead and make it a little bit different by changing the custom minimum size to, say, 300 by 200. Not that's too big. 300 by 100. There we are. 250. There we are. Down here in theme overrides, we are going to add in a theme override just so that doesn't look exactly like that. These are going to be your secret ways of customizing everything you want. So feel free to have fun, play around with all these values, make it look however you please. But here's the secret sauce, content margins. A lot of people, first-timers, don't realize this exists. This tells the container, how far inside its children should be. So let's add a button to this container. If you take a look, the button got added inside of the container, but let's change the color of the container so you can see it. The button got added inside of the container 5 pixels in from each side, but it is the size of the container, and that's what a panel container does. All of the children of the panel container are the size of the panel container with the margin, right? So we don't actually want that. We want to add more controls to give us a more buttony layout. So let's add HBox, a horizontal box container. And then we'll also add a VBox, a vertical box container. How fun, right? So let's put in a button here. Button. We can add in as many buttons as we want, and they get laid out horizontally because this is an HBox container. Let's find a color that is just, there we are. Go ahead and leave it bright for now. You can see we've got a button row setting up here. And if we were to do the same thing inside of the VBox, you can see how they go up. But we actually want that to be just a couple of buttons. We want the buttons to be as big as possible. So, buttons. Buttons. No, I don't want a bone attachment 3D. Goofball. You do have to spell things right. It's a downside of programming. Over here under layout, we can change this to fill. Now we can create a second button. I've got 2 buttons. Put the VBox container between them. Create a new button in here. We'll come over here to the layout and fill vertically. These buttons are too small, so let's make these buttons wider. We'll go ahead and set them to have a minimum X size of 100. There we are. We've got some buttons layouts. Easy as. Let's go ahead and name them. Left, right, up, and down. These buttons currently don't do anything. You can click them, but they don't do anything. Every time you click a button or really do anything even vaguely near a button, it emits a bunch of signals, but we aren't listening for those signals, so nothing is happening. In order to listen for the signals, we need some code. Don't be intimidated. We're just going to add a script right here. We're going to go ahead and call it basescene.gd. Now, basescene.gd is not the same as basescene.xln because this is a scene file, and this is just a script file. Oh, do we have to type something? How do we make code here? I'm immediately intimidated. Don't worry about it. What we need to do is go over to these buttons and have them do the work. We want the press to work, so we double click the pressed, and there we are. Now we'll just add in some print functions so you know that something happened. So when we run this now, take a look down here. The buttons now do something. Brilliant. So, how do we go from this to a video game? Well, we've already saved this file. What we really want is a whole bunch of files very, very similar to this. We want scenes that look and act exactly like this, but do specific things. We have a new version of this. So we're going to go ahead and save this as Kerbal scene. It looks identical. They are the same because one descends from the other. But here in Kerbal scene, we can make changes, and it will change just this Kerbal scene. So if we were to change this texture to the Kerbal texture, oh, look at that. We now have Kerbal scene having a different visual. And if we were to run this, play this scene, you can see that it has all of the same up, left, right, left stuff, but it has a different visual. Similarly, here in the Kerbal scene, we can disable some of these buttons. Let's disable these 3. And if we save that and we run the Kerbal scene, we can only click this left button. These are now disabled. But over here on the base scene, if we run this one, they're all still enabled and we're still using the same background. In fact, this is a little bit dangerous because this background is viable. It doesn't look like a placeholder. So we're going to want to change this background to something that cannot possibly be mistaken for correct. So let's change it to... Oh, I think I accidentally deleted... I deleted our little blue guy that comes with the script. That's fine. We'll just use this. Boom. It's very obviously incorrect. So now, when we hit F5, oh, look at it. We started here. This is one of the things that you're going to want to keep an eye out for. Depending on how you tell the game to run, it can run the default scene that you've got set up, or it can run the scene you're currently in. And it's easy to accidentally run the wrong scene and get confused. We can play this scene here, and we can also, change the default scene. There we are. But let's have this button actually do something, right? Well, before we get there, we need to have something for it to do. So let's create one more descendant. Make sure you're descending from the base scene every time. You never want to descend from one of the descendant scenes unless you're doing something specific. So here we are. We're going to save this as a Dragon's Dogma scene. And we're going to change the visual to the Dragon's Dogma screenshot. There we are. We're going to disable these 3 buttons. Boom. So now we've got the 2 scenes here, one with the left and one with the right. I think you can see where this is going, right? So here's the other trick. We can use a built-in script for this. We don't have to save it to a separate file. It's empty. Oh no, what am I going to do? Well, it's not a big deal. You see, we already set up this right button. Was it the right button? Yeah, it was the left button. We've already set up this left button to go to on left pressed. We can hit go to method, and it will try to pull up that method for us, but that method does not exist because it's in the parent. So this still works. If we were to hit F5, it still says left. What we want it to do is actually do something instead of going left. We could copy this. That would work fine. We can also type in func space and then start to type it in, and it will sort of fill it in for us. Either one of those works fine. So how do we create a new scene? Well, we want to remember to delete ourselves. Q-free deletes yourself, or whatever you're calling it on. So this will get rid of us. And if we were to run from here, boom, it just deletes itself. Because we don't want to have a million Kerbal scenes in the background every time we switch back and forth from Kerbal to something else. How do we actually load the scene? So we type in load. Oh, look, it's got all these suggestions for us. Now you could try and find the scene you're trying to load here, but the easier way to handle it is to just drag it in. Boom. We've now loaded that. But here's where the game engine gets a little bit obnoxious, because this does not actually load it onto the screen. This loads the scene definition into RAM, which is not super helpful. So once it's loaded into RAM, we have to say, well, could you please make it into a node for us? Because all of these are nodes. So that will turn it into a node. But it's still not on the screen. So now it's just a node hanging out in RAM. So to put it on the screen, we've got to do this. Get tree.root.load. There are a couple of other ways. Oh, sorry, add child, my bad. There are a couple of other ways to do this, but this is by far the most common one you'll see. What this does is it says get tree. For some reason, Godot calls the base game scene tree. Then we say root, which says get whatever the first rendering node is. And then we say add child. And that puts this node that we've created into the scene. So, boom, there we go. This is basically a magic incantation. You don't have to remember it. You can look it up every single time you ever use it. Nobody will care. You don't have to worry about it. But what you do have to worry about is the fact that it exists at all. You have to remember that you do have to do this. If you're trying to put a scene into the screen and it's not popping up, it's usually because you forgot to actually add it to the screen. So you don't have to remember how to do it, but you have to remember that you need to do it. Every time you search, it'll pop right up, but you have to know that you need to do it. So now we're going to go over into our good friend, the did scene, and repeat the process. Except for this one is on right pressed, and instead of loading the did scene, we want it to load the Kerbal scene. So now when we play it, easy as pie, right? So you might be wondering why we're not using this. This is something you see a lot when you look at tutorials. If you drag it in without doing any kind of button clicking, you get this the path, right? But if you hold control while you drag it in, you get this preload. Preload can be extremely useful, but there is an issue. Godot has an extraordinary allergy to circular references. If you put a circular reference in Godot anywhere, no matter how tenuous, Godot will immediately corrupt all involved assets. And you have to manually edit the assets using a text editor outside of Godot in order to recover them. Yeah. There's no other game engine that really does that. Most game engines are smart enough to understand that people might want to leave a room and then go back in, so circular references should be allowed. But Godot still doesn't get that part. That is one of Godot's major problems. So preload will trigger that problem. Preload will immediately say, when you're compiling the scene, the compiler will say, oh, this DD scene, it needs to load this immediately. So let's go over there and load this. Oh, wait, this is a loop. Well, I don't know what a loop is, so I'm just going to permanently corrupt the file. So only use preload if you're preloading assets that are below, like they're not going to cause any sort of loops. Otherwise, you're going to want to use this kind of setup. Load does not trigger it because it happens at runtime instead of at compile time. And that's all nonsense to you. If you didn't get any of that, just remember that preload, this word preload, is super dangerous. It can permanently corrupt your assets. So only use it if you're absolutely sure it's okay. Oh, by the way, that also includes this is the exact same as preload. So if you see this same setup, it's a preload. Be very careful. You do not want to cause loops. You do not want to cause these things to resonate with each other because you'll just brick your assets. So we've got it working. Let's talk a little bit about how to make it not suck quite so much. Right now we've got this thing where it just kind of flicks back and forth. What we really, really would like is some verve. Let's add some animations. Here is where we learn about the glorious secret of the base scene. You might be wondering why we're using inherited scenes rather than, say, duplicating the scene. Let me show you. If you make a change to the base scene, it propagates to all of the inherited scenes. So if we were to change how our buttons look, they will just look different on every screen. But we can still customize it per screen if we want. If we want these Kerbal buttons on this screen here to have Kerbal faces on them, we can do that. And it won't affect any other scene. But if we wanted to change these buttons to have like sigils, runes, or whatever, and we did it on the base scene, it would affect everybody. So we can create these kind of half-assed layouts and then polish them later because our scenes all inherit from this layout. So if we change this layout, it changes it for everybody. Watch. Hold on. Save. Easy as that. But what this means is that we can do stuff like this. Now let's add it here to the panel container. Animation player. Animation player is now added to all of the scenes. Let's name it something. Let's name it %anim. Save it. There it is. Now this %sign means that it's very easy to find in code. Huh. Well, that'll be handy. Let's go ahead and create a new animation. We're going to call this fade in. And we're going to want to make it so that it fades in the scene. So we'll come here to control. And we will have this control. Let's go ahead and have it do an actual fade in. Down here in visibility, here's modulate. Modulate is the color of yourself and all your children. Self-modulate is just your own color. So if we were to set self-modulate to pink, you can see the buttons do not become pink. But if we were to set modulate to pink, everything becomes pink. See? So what we want to do is we want to set the modulate to transparent, but we want to do it via animation. So we're going to use this key button right here. This only appears if you're currently editing an animation. You can go ahead and set that here. So this needs to be transparent. And it goes, whoosh, whoosh, see, comes in. But let's go ahead and make it a little bit more fun than that. Let's make the panel container that contains the buttons do the same thing, but slower. Save that. Now, how do we make it play automatically? You might wonder. This makes it play automatically. So now, when we load the game, see how it fades in? Easy as that. But you know, what would be really nice is if the old scene faded out first, and then the new scene got loaded in. How do we do that? Well, it's not that hard. We'll just create a custom script that does this. We want to do this, but the same for every time we ever switch. So up here in the base scene, we'll create a new function. We'll call this load. Why not? And then we'll have a scene name. And then this will be scene name. Like that. Easy as that. But we do have to refactor. Now, if you ever find yourself doing this, it's absolutely fine. There is no reason to worry about it. But you can see we've overloaded this function name. So if we were to do this, how does the system know whether we want to do the load that originally existed or the new load we just created? Well, we could do something like this, but it makes more sense for us to be more careful with what we name our functions so they don't overlap with anything else that exists. This is a better name because it doesn't share a name. Oh, I forgot to actually copy it. Load scene. Better, right? And we'll do the same thing down here. This is called refactoring. It happens a lot. Do not feel like you are wasting time or there's an underscore. Do not feel like you're wasting time or that you did the wrong thing. Refactoring has a time-honored tradition. Please remember that programmers are basically just plumbers. Most of us are dumbasses, and we're not too quick on planning things ahead. So refactoring is something you'll do a lot of. Don't worry about it too much. Just don't get stuck refactoring things you don't need to. Like if you're spending 8 hours a day refactoring your code, you should probably have tried a little bit harder originally and find a way to make it work the way it is rather than spending all your time refactoring. Anyway, we are now using a centralized function to switch between these places instead of having it custom for every single one of these. The advantage of that is that we can add in some cute little effects. So let's go ahead and fade ourselves to black before we load in the next screen. Now we could do that by simply trying to play this animation backwards, but if we did try and play this animation backwards, it would fade to transparent, which would end up creating like this gray flash because the background here is gray, and we have to do something about that. It seems annoying. What we're going to want to do is fade our screen to black, wait for the new screen to finish fading in, and then we'll get rid of ourselves. So we're going to need a new animation. By the way, this animation is called a reset. The reset animation is what happens when no animation is playing, which is good to know. You may need that information. But let's create a new animation. We can't. Why can't we? Well, because we are editing a child node, and this is a parent object we're inheriting. So we need to go back to the base scene, and then we can select this and create a new animation. I'm going to call this fade to black. And now this extremely complicated animation is going to fade to black. Opaque black. And we're going to assume that it starts as white because it almost always will, rather than starting as transparent. So we'll make this a half-second long animation. 0.5. And it'll just go black. like so. So we'll go ahead and save that. And we will come over here into our descendant scenes and just see, yeah, that should work fine. In the script, we're going to want to play this animation. So anim.play. Oh, I didn't like that. Is it different? Is it play animation? Anim dot. Why are you not auto completing? There it is. We have to be in the scene that it exists in. That's fine. There it is, fade to black. And then we can await that. This is a keyword you might not be familiar with. It's the most powerful word in Godot. Awaiting means that we will just stop doing anything in this function until that signal happens, at which point we will continue. This can be any signal. We can await a certain button being pressed. This allows us to create quite complicated gameplay out of just this kind of very basic code. So anyhow, we're going to want to start to plug our scene in, and then we're going to want to wait for our fade to black to finish. This scene has its own animation. It is fading in while we are fading out. Now, fading to black doesn't take very long, so we're going to want to also await a little bit longer. So we're going to go ahead and create ourselves a timer. And then we'll go ahead and wait for it to time out. There we go. And then we'll queue free. Now, it might not seem like we've changed that much, but we are now fading this scene to black as the next scene fades in, rather than snapping. So there's no gray pulse. If you wanted to see how it was before, we can take out these awaits. See that gray pulse? That gray pulse no longer happens if we wait for this animation. Very, very silky smooth in comparison. And you've now learned how await works. So let's go ahead and do a little bit more with await. Here in this DD scene, let's go ahead and create some interactivity. So let's create some buttons. Because we're creating buttons in the child scene, they do not exist for anyone else. They don't exist for the parent scene or any of the other children. They only exist within this one scene, so we can do whatever we want with them. Let's have it so that we can talk to Talia by clicking on her name. And we can drag this down here so that when we resize the screen, it will keep it in place rather than zooming it around all the time. And this button, we can go over here to signals, pressed, and just create a new thing. I'll call this on Talia pressed. Oh, we'll go ahead and say something. Print. Let's have it do something. So let's have it so that when we come into this scene, it's actually completely disabled. And let's make it so that we re-enable this right button. But how do we access the right button? Well, we can't just type %sign right because they do not have this little symbol next to them. So let's go back to the base scene. Let's highlight all of these buttons. Access as unique name. Now they do. So now over here in the DD scene, we can say print, let me unlock that for you. Right, dot disabled equals false. Disabled is true. Now it's going to be false. But what if we wanted some kind of text pop-up? Sure, let's have fun. Put in a panel container. Let's drop it in the middle somewhere. And then we will add in a text box. And we will fit that content, and we'll go ahead and have it have a specific minimum size. How about 200 pixels wide? And then we'll have the text be, Talia says, if you want to leave so badly, let me send you far, far away. But that doesn't look very good. Let's go ahead and override the theme. so that it doesn't look quite so awful. The big thing it needs is content margins. Maybe this. And then we'll go ahead and just curve it a little bit. However, you know what it needs? It needs some borders. Exciting stuff. So, Talia says, if you want me to leave so bad, if you want to leave so bad, leave it. So let's go ahead and name this. We'll name this Talia speech. And we will just make it transparent. We could also make it invisible. Either one works. So one of the things we want to do here is we don't want it to overlap with this bubble. So we're going to have this mouse just say ignore. That way, when we click on this area, it's not going to click on the text box. It's going to ignore the text box. So now we can also create a new animation node, because we could just layer animation nodes however we want. And then here in this new animation node, we'll create a new animation called fade in. And as you might expect, we are just going to fade in. Make it a full second. Why not? Be luxurious. We can also do this. So it fades in a different pattern. So it goes a little faster. Yeah, I think that works great. So what we're going to want to do is not click this. We are not clicking this because it's not going to pop up until Talia says something. So here in Talia Pressed, we're going to say, well, we need a way to play this. So we're going to play it as Talia anim. Percentage sign. So Talia anim. Dot play. Fade in. Oh wait. Talia anim. Dot animation. Finished. Oh wait, get tree dot create timer. We give the player 2 seconds to read it. Dot timeout. This dot timeout makes sure that we're awaiting the signal timeout. If we don't put a timeout at the end, the game won't know what it's awaiting for, and it will just run the timer in the background and nothing will happen. And then we're going to do this again, but we're going to play it backwards. To play it backwards, you just put in, well, look at all these arguments that pop up. There we are, playing it backwards. I hope you enjoyed this very goofy little intro into how to use Godot a little bit. From here, you might be thinking, how do I add in inventory items? How do I add in? Great. That's what you need to be thinking. Whenever you are inspired to think about how you're going to do the next step, that is a moment where you're going to be able to do the next step. Because how do I is a more powerful phrase than what do I. If you're not sure what you're trying to do, how are you going to learn how to do it? But if you have a goal in mind, if you're trying to extend something, it becomes much easier to look up how to extend it. The difficulty is, of course, if you're building on shaky ground, it can get a little bit dicey. So you might find that this little basic tutorial is a little bit annoying to extend into a full-sized game. That's fine. We've built it so that it is relatively easy for us to change how it works. So you can do that. For example, we could change the buttons into variables on the scenes rather than manually typing in load scene list. We could have like export var other scene string name, that sort of stuff. Right scene. But when you do this, you must always keep in mind that Godot is allergic to circular references. So once you do start to extend this up, be careful not to create circular references or Godot will hunt down your family and murder them, which is a little unpleasant. So, just so you're aware, Godot is otherwise quite forgiving, and even if you do accidentally brick all of your scenes because of a circular reference, it isn't that hard to manually go in and delete the reference. And even if you have to delete the whole scene, that's not a huge deal most of the time. So it's, just keep your chin up, and if you get stuck, realize that everybody else has been stuck in the same place many times. And if you have a hard time looking up the solution, that's because Google completely shit the bed recently. It's not because you're bad at it or you're going through something unique. Just hunt down someone that actually knows how to do Godot and ask them what the hell went wrong. And they'll probably know immediately because they've already had it go wrong for them too. See you around.